Joystick Junkies, welcome to another video. Now today we're going to spice things up a bit and we're going to get a little bit quirky. Now you might be wondering, Junkie, what are you doing in Microsoft Paint right now? And you have a very good right to think that. But today, don't fear, because we are going to go over the complexities of calculus in a sub-genre known as limits. Now, where do we begin? So, if you are looking up help for calculus, we all should know what a graph looks like. Okay? So limits has to do a lot with graphs and how to read graphs. So, of course, you know this is 1, 2, 3, 4, so on, and this is y, 1, 2, 3, 4. Now, if you have a very basic function like x squared, alright, we should all know what x squared looks like, but if you don't, that's alright. And it's just a nice parabola that goes something like this. That's actually very bad. Don't judge that. It looks like something that goes like this. There we go. Now, what limits is basically trying to do is hone in on one point of this graph and asking you, what does this function approach? What value does this come close to? So a very basic one would be, what is the limit? This is what the notation looks like as x approaches 0. So, of x squared. So, if we have limit of x right here, x is the value we're looking at. So, we'll be looking along the x coordinate. Approaches 0. So, x of 0 would be right here on the axis. So, what y value does x approach when it's approaching 0? And if you look at the graph, it approaches 0. So that would equal 0. Now, let's say we got rid of that, and we wanted to know what was the limit as x approaches 1 of x squared. Now we do the same exact thing. The only difference is we're looking at x1. So we go over to x1, and we go up to where the graph of x1 is, which would be right around here. Now, we can see that from the left, it's approaching 1, and from the right, it is approaching 1. We want to make sure that the limit approaches this value from both sides, because later this is going to come into hen. Now, let's throw in another one. So, if we have the limit of, let's say, 2x, no, my bad. Let's say of x and the limit of negative x on the domain from 0 to 2 and negative x from 3x to 5. Now, if we plot x from 0 to 2, it would be something like this. Right? Now, so we'll label this the graph of x, of negative x from 3 to 5. So it would be something like this. Now, oh no, this is a bad example. Let's change this to 2. Okay, now what we want to do is go right here, and we'll say, my bad. Let me erase this. So, 2 is less than or equal to, is less than x. So, now let's say we're asking for the limit as x approaches 2. Now this, of this, which say this whole thing is f of x. So let's say that the limit as x approaches 2 of f of x. Now, if we look, we can tell from the left, left being from negative x all the way to positive x, or negative infinity x all the way to positive infinity x, from the left, it approaches positive 2, right? But from the right, going this way, we see that it approaches negative 2. So when it's asking for the general limit, which is when its limit of x approaches a number without anything added to it, and these graphs approach two different numbers, the limit does not exist. That is what we write in calculus when the limit cannot be evaluated. And make sure you never write equals does not exist, because that is not proper notation. Whenever you have a limit does not exist, you just simply write D and E beside it. Now, if we want to do something a little bit more crazy, then what we do is we can ask for something different. And let me try blanking my screen. Hold on. Alright, there we go. So let's say we have our graph again. We'll go to graph. This time we're asking for the limit of the same as x approaches 1, or x approaches 2, of f of x of the same thing we were talking about, of the same function we were talking about from before. My bad, don't disregard that. Of the same value as before, the same function. But this time, we go up to this limit notation and we write a little negative beside it. Now, if we draw the same graph, that's x, and this will be negative x. Now, when we look at the interval notation, we can look at this here and see this little negative sign out in front of the 2. Kind of looks like an exponent. What we can do is this is basically saying the limit as x approaches 2 from the left. Whenever you see a negative, it means from the left. So we completely disregard the right side of the graph. The right side of the graph does not matter when we're talking about from the left. Now, since we're only focusing on the left side, we can see that the graph approaches 2. As opposed to last time we were asking for the general limit, or a limit that doesn't have a negative or a positive on it. This would act as a value. This one would equal 2, because from the left, we can see that the graph is approaching 2. Now, if we change that, and we change this exponent to a positive instead of a negative, what you'll get is what is the limit as x approaches 2 from the right, which then we can use the right side of the graph. So anything on this side, anything to the left of 2 does not matter. And we're simply looking from the right, which would be going that way. And we can see that the limit is approaching negative 2. So you see that this notation matters a lot for the value you get. Now, that's why the general limit doesn't exist, is because when you have nothing in front of this 2, then this limit does not exist, because the left approaches something different than what the right approaches. So for one final example, what I'll do is I'll get a graph here. And I'll say the limit as x approaches 1 of x. Oh, my bad. Of f of x. Now, the trick is f of x equals x, but x does not equal 1. So now this might be a little tricky, but let's treat this thing as everything else. So x, what we would do is we'd go, and x doesn't equal 1. So if we know, we can just put a circle here to represent an undefined value. And then we keep going with the normal x graph. And it looks something like this. Now, we can look at here, and this might throw you for a loop because you're seeing that x, the limit, is asking for a value that is undefined. The value isn't there. But when we're asking for limits, the value does not have to be defined. The value, it's basically just asking for what does the graph approach? What does the graph seem to be doing as x approaches that number? And as we can see, x is still approaching 1 in this example. It's approaching 1 from the left, and it's approaching 1 from the right. Even though 1 isn't directly defined, 1 does not, x does not equal 1. The limit is asking for what does the graph, what does the function appear to be moving towards. That's all limits are about. Another thing that might trip you up is, let's say we have the graph that looks something like this. And we're asking, we'll call this f of x. So we'll ask, as x approaches, now don't let this scare you, infinity of f of x. Now, x approaches infinity, so that means pretend that this graph goes on to infinity. As x approaches infinity, pretend that this graph goes on forever. Now we can see that the graph goes down. As x gets bigger and bigger, the graph is going that way, and it's getting closer and closer to the x-axis, which means that the y value is getting closer and closer to 0. So anytime it's asking for a limit as x approaches infinity or negative infinity, you can always say, it's basically just looking at the ends of the graph. What is the ends of the graph it appears to be doing? If it was different and it was asking for the limit as x approaches a negative infinity, you just simply look at the left side of the graph, and you would see that that y is approaching infinity. Because as x gets smaller and smaller, y gets bigger and bigger because it keeps going up in exponential form. And that is pretty much all you have to understand about limits and how they work and why we use them in math. And I hope this video has helped, because we are all, stressing out for the AP exam, and we all might be a little bit nervous. But hopefully this video will be one of many, and I'll try to cover every category of calculus before the AP exam, so we can all sleep well at night knowing that we could ace this calculus exam. Hope you guys have a fantastic night, and Junkies out.